Hey all listeners, let's see this question of Irodov. It's a question of hydrodynamics. Question number is 1.326. Question states, on the opposite sides of a wide vertical vessel filled with water, two identical holes are open, each having the cross-sectional area S. The height difference between them is equal to delta H. Find the resultant force of reaction of water flowing out of the vessel. Right? Suppose we have this vessel, and on this vessel water is filled like this, and there are on the opposite sides two identical holes are open. Suppose there is this hole here, and on here this is this hole. Both have area S. This is also has area S. So at this moment the velocity coming out here is say v1, and velocity coming out from this hole is v2. The difference between these two holes in height is delta H. If I take this height to be say h1 and this height to be h2, and this is a wide vertical vessel, so this is a very large area compared to this area. So we can directly apply the Torricelli theorem for the velocity of flux. So v1 is equal to square root of 2g h1. So v1 square is 2g h1 and v2 square is 2g h2, right? And as the water will go out, so if we take this cylinder as a system, so from the variable mass problem result, thrust force will act opposite to the velocity of flux, and that thrust force expression is F thrust is equal to rho into area of cross section A into velocity square. So one thrust will act here opposite to this velocity, and this is say F1. And because of this water coming out with velocity v2, another thrust will come here, that would be F2. A resultant of these thrust will F2 will definitely be more because v2 is more. So resultant of them would be F net. F net. So F net is F2 minus F1. And F2 minus F1 for each row area into velocity square. Area of both holes are S, so this would be rho S into v2 square minus v1 square. v2 square is 2gh2, v1 square is 2gh1, v2 square minus v1 square is 2gh2 minus h1, and h2 minus h1 is delta h. So this is a rho s into 2g delta h, and that is F net.